Hi everyone, I'm Seungheon, a PhD candidate from KAIST, South Korea. In this talk, I'm going to present our paper, LP-MusicCaps, LLM-Based Pseudo Music Captioning. This work was a collaboration with Choi, Jongpil, and Juhan. Let's see a video demo of our captioning model. Our model generates nice captions that describe the input music.
Gotta take deep breaths when you exhale, 1, 2, 3, and then you'll hear yodel if you listen close to me.
Okay, what is music captioning? Let me first define it. Music captioning is a task to generate natural language descriptions of given music. There are quite a few applications already of music captioning. For example, music captioning can currently be used for subtitle generation for video content. You may remember that you saw subtitles like Jazz Piano with Swing Fill when you are watching a movie. Another recent application is an AI DJ. As a listener, we expected the AI DJ to talk about the music, right? And this is exactly what music captioning is about. Little different, but we can use music captioning for playlist title generation or track name generation. And I think there are going to be more application of music captioning. For example, think about the text-to-music generation. A good captioning model would be helpful to create the dataset for music generation models. And that was just an example that we already can see. But there will be a lot more. I want to even say language is the interface of the future. Language is effective because we can describe a lot of things about music using language. Let's talk about the presentation. In the part 1, I will talk about the LLM-based dataset generation. This part is about converting a list of text to caption using a large language model. The second half, part 2, is about captioning model. I will introduce how we use the result of part 1, the pseudo caption dataset, to actually train a model. Our starting point is the lack of music caption paired dataset. Natural language annotation requires musical knowledge, making it more costly to annotate. Previous research in music language pre-training represented by captioning or joint embedding approach has used the music caption paired dataset. However, with the exception of MusicCaps from Google, these datasets were privately owned by companies. MusicCaps is a high-quality dataset annotated by 10 musicians, but it is limited in quantity for both training and evaluation. Let's return to the problem. We lack a large-scale music caption paired dataset. Instead, we have a music multi-tag paired dataset. We focus on tags obtained from Last.fm or music. Note that the tagging dataset is almost 100 times bigger than existing music caption dataset. Only problem is there has no captions. So it would be really great if we can use this tagging dataset as a caption dataset. We can do that using large language model. We generate the caption using given tags and a large language model. This approach is not limited to tagging dataset, but can be applied to any dataset with a language expressive labels. Let's formulate our pseudo caption generation process. We input text and instructions into LLM and get pseudo caption as the output. The amazing thing about LLM is that when we change the instructions, the output changes. For example, if we put summarize in the instructions, the output becomes shorter. For the same tag list, we can control length and remove redundant information. If we add creative paraphrasing, we get diverse expression result. If we prompt LLM to predict attribute with given text, we get new information from LLM corpus. Now let's evaluate the generated captions. An easy way is to compare them with the human captions. First, we measure the n-gram overlapping between two captions, and we measure the diversity of the generated captions. We check the total vocabulary size or new vocabulary used. We measure BERT score semantic similarity with a pre-trained language model. We compare our model with the three baseline methods. First one is tag concatenation, second one is template, and third one is T5-based keyword to caption augmentation. Our proposed model outperformed them baselines in terms of the n-gram overlapping, diversity, and semantic similarity. We compare proposed instructions, writing excels in n-gram overlapping, summary strength in semantic similarity, and paraphrase attribute prediction shows strength in diversity measure. After objective evaluation, we conducted a subjective evaluation through an A versus B user preference test. Here, A always represents human captions, which help us measure if our pseudo caption can perform on par versus human captions. We ask users that which caption is a better description for true positive and which caption is less wrong information for false positives. We compare our four instructions with the human captions. In 6 out of 8 cases, our proposed method achieves human-level performance. 2 cases are interesting. Summary compresses the information too much, showing weakness in true positive, while attribute prediction increases false positive due to hallucination. After validating our proposed method, we transformed the existing large-scale tag dataset into a caption dataset, and we released the dataset. This is the end of part 1. Main point of part 2 is start from the one question. So, can we really use this dataset to train a captioning model? To answer this question, we train a captioning model with a pseudo-caption dataset. With a cross-modal encoder-decoder architecture, our evaluation dataset is MusicCaps evaluation split. So we divide the 3 training setup. The first is the out-of-domain setup using the pseudo-caption dataset, LP-MusicCaps. The second is our in-domain setup using the MusicCaps training split. In the out-of-domain setup, our method shows higher n-gram overlapping and semantic similarity compared to existing caption generation methods. In the in-domain setup, our transform model outperforms the supervised model, demonstrating the effectiveness of the pseudo-caption dataset. You can download our pre-trained weight from Hugging Face. Also, we release our dataset, model, and web demo. Here is our contributions. First, we introduced a pseudo-caption generation method using a large language model. Second, we proposed and compared 4 tag-to-caption instructions and evaluated their performance. Third, we built a new 2.2 million pseudo-caption dataset, LP-MusicCaps, using existing audio tag paired dataset. Lastly, we trained an audio-to-caption model using the pseudo-caption dataset and showed promising result. Thank you for watching this presentation.